Welcome back to the deep dive. Today, we are taking a trip right into the heart of modern cybersecurity operations.
Right into the engine room.
Exactly.
Yeah.
It's a world of, rapid fire incidents, just tons of data, and the absolute need for automation. So if you're looking to get a quick and really comprehensive handle on what governs modern cyber defense, things like incident response, behavioral detection, then you are in the right place. We've gone through a huge stack of documentation, all centered around the SecOps-Pro framework. And what it gives you is this, X-ray view of what the industry thinks are the most critical skills to have right now.
That perspective is so important, and the emphasis is really clear when you look at the numbers.
How so?
Well, a full 25% is just on security operations fundamentals, the absolute core concepts.
The foundation.
The foundation. And then the tech supports that. You have Cortex XDR and Cortex XSIAM making up over 40% of the material. That shows you the shift, toward advanced detection and unifying all that data.
And the rest.
The rest is about execution. Threat intelligence, incident response, and Cortex XSOAR. They each get about 16%.
So the message is, know the process, not just the tools you're using.
That's it, exactly.
Okay, so that's why we're structuring this deep dive less like a tool review and more like the actual life cycle of an incident.
Yeah.
And we're going to start at the end.
The part everyone forgets.
The part everyone forgets. Because if you don't learn from a fight, you are absolutely guaranteed to lose the next one.
Yep.
So let's talk about the NIST incident response lifecycle. The team did it. They contained a complex attack, the threat is gone, the environment is clean. What is the one critical step that has to happen right after that?
Not the pizza party.
Not the pizza party, no.
It's the post-incident activity phase. It's crucial. In the chaos of the actual response, everyone is just focused on putting out the fire.
Right, real-time mitigation.
Exactly. But this post-incident part is where you extract the real value. It's like the analysis of the analysis.
So what does that look like?
It means collecting all the documents, reviewing the timeline, and most importantly, doing a real deep dive into how effective the response actually was.
Like, did our plan even work?
Did the run book work? Where did the policy fall short? Did we have the right visibility? The goal isn't just closing a ticket. It's creating updated policies, new run books, and refined procedures that make the whole organization stronger for the next time. If you skip this, you're just letting that technical debt pile up.
And the attacker barely has to change anything to get you again.
Exactly.
I think that's such a key insight. Cyber defense is less about perfect tools and way more about that continuous loop of improvement. Okay, so from improvement, let's talk about efficiency. The biggest headache for any security operations center, the SOC, is just noise. Alerts, alerts, alerts.
They're drowning in it.
They are. But good security isn't just about catching the bad stuff. It's about being quiet when nothing is wrong. So when a security scanner correctly finds a totally clean, benign file and generates no alert, what do we actually call that perfect silent outcome?
We call that a true negative. It sounds, a bit boring.
Right.
But it might be the single most important metric for keeping your analysts sane and on the job.
How so?
Well, look, if an analyst gets 10,000 alerts a day and 99% of them are false positives, false alarms, that person is going to burn out. They'll quit.
Or they'll start ignoring things.
Or they'll start ignoring things. A high rate of true negatives means your detection logic is working. It's correctly seeing benign stuff and choosing not to bother the analyst. It's the difference between a finely tuned instrument and a car alarm that goes off when the wind blows.
It's the metric that proves the system isn't crying wolf.
That's the perfect way to put it. It builds trust.
Okay, so now that we know what good and quiet looks like, we have to talk about categorizing the bad behaviors we do see. So instead of just an alert like malicious IP detected, how do analysts actually categorize what the attacker is doing? Things like process injection or credential dumping into known methods.
This brings us to what is pretty much the industry standard. It's the knowledge base everyone uses, the MIT AT&CK framework.
And what does AT&CK give an analyst that just, say, blocking an IP address doesn't?
Well, blocking an IP is reactive.
Right.
AT&CK lets you be proactive. It gives you this huge structured matrix of adversary tactics, techniques, and procedures. We call them TTPs.
TTPs, okay.
So instead of an alert that just says registry key modified, the analyst can map that specific action to the persistence tactic and a specific technique, like, say, T11-117.
And what does that mapping actually do for them?
It changes the whole conversation. It shifts it from a single, isolated event to a full campaign objective. And analysts might see 3 different, seemingly unrelated alerts, but if they all map to the lateral movement tactic in ATT and CK,
They instantly know the attacker is already inside and trying to move deeper.
instantly, it gives everyone a common language and a structure for sharing threat intelligence. It's globally understood.
So the TTPs are basically the adversary's playbook, and our defense has to be just as smart.
It has to be.
But even the best intelligence can get old. It gets stale. So let's connect this back to hygiene. If you have an indicator of compromise, an IOC, like an old malicious IP from a campaign that ended months ago and is now causing false alerts, what's the process for cleaning that up?
That process is called indicator aging and expiration. It's basically just good database management to fight bloat.
So you put a timer on these indicators?
Pretty much. If an IOC is inactive for a certain amount of time based on your policy, it gets flagged for expiration and eventually removed. And the consequence of not doing that is severe.
You're back to the noise problem.
You're right back to the noise. Stale IOCs create constant false positives, analysts waste time verifying things that are harmless, and your true negative rate just collapses. Good aging is foundational.
Okay, that's a fantastic overview of the fundamentals. Now let's get into the advanced tools that use this kind of intelligence, specifically Cortex XDR. Adversaries are not just dropping simple viruses anymore. They're living off the land, right?
No.
Using legitimate tools, PowerShell, WMI, to download and run malicious code in a sequence. How do you catch that sequence when each step on its own might look totally normal?
This is where we get into, you could call it Security 3.0. And the tool for this is the Behavioral Indicator of Compromise, a BIOC rule.
A BIOC. So how is that different from, say, traditional antivirus?
So it's a whole different ballgame. If traditional antivirus was 1.0, just checking a static file signature,
The fingerprint.
a fingerprint, and then maybe EDR was 2.0, checking file properties and processes. BIOCs are 3.0. They're designed to understand context and intent. They aren't looking for a bad file name. They're looking for that suspicious chain of activity.
So did a word macro run?
Exactly. Did a word macro run? Did it then call PowerShell? Did PowerShell then connect to some weird IP address? Did that then execute a process? BIOCs look at the whole process lineage, the correlation, the order of events, to find that malicious pattern hidden inside legitimate actions.
That's how you patch fileless attacks.
It's the only way you catch them reliably.
That's a huge step up. Okay, so let's say we detect this kind of thing, a file that's acting weird, but it's totally unknown. We can't just run it on a production machine to see what happens.
No, definitely not.
So what specialized service gives you that dynamic analysis, a safe way to see exactly what that file does?
That service would be Wildfire. Wildfire is a cloud-based dynamic analysis service. It's a secure sandbox.
A sandbox.
Yep. You submit the unknown file, it gets executed in a totally isolated virtual environment, and its entire behavior is watched and recorded. What files does it drop? What network connections does it try to make? What system calls is it making?
So you get all the forensic evidence without any of the risk, but what about the trade-off there? I mean, latency. If you send every single unknown file to the cloud, doesn't that slow things down?
That's a great question, and it's a key design point. Wildfire is optimized for speed, but more importantly, the endpoints, the XDR agents, they have on-device analysis to handle most known or, sort of known threats right away.
So Wildfire is for the really weird stuff.
It's for the truly unknown, the potential 0 days. And once Wildfire makes a decision, malicious, benign, whatever, that intel is shared globally. So the next time that file shows up anywhere, it's blocked instantly without needing to be analyzed again.
Very cool. Okay, so high-fidelity detection, safe analysis. Now the response. A malicious file is confirmed on a Windows endpoint. What are the two direct, absolutely essential actions an analyst takes from the XDR console to contain that threat immediately?
The goals are containment and stopping the bleeding. So first, you have to isolate the endpoint from the network.
Cut it off.
Cut it off. This stops any lateral movement, stops data exfiltration, cuts off communication to command and control servers. But, and this is a crucial detail, the isolation still maintains management connectivity.
So you can still talk to it.
You can still talk to it. You could push commands, pull forensic data, clean the machine. If you cut off everything, you're flying blind.
Okay, so that's one. What's the second?
The second is to terminate the malicious process. Just kill it. Stop its active execution right away. That stops the immediate harm while you deal with the bigger picture of isolation and forensics.
Perfect. Detection, analysis, containment. Now, let's scale this up. We've talked about XDR, but what happens when you have 50 other security tools? Firewalls, cloud logs, identity providers, all spitting out logs in 50 different formats.
The nightmare scenario.
Right. And that brings us to Cortex XIM. What is the main reason for mapping all those raw logs from all those third-party vendors into the XIM data model, or XDM?
The primary purpose, in one word, is normalization. And this is, I would argue, the most important architectural change that a platform like XIM brings to the table.
So what's so bad about different formats?
Think about the logistical mess before something like XDM. Integrating 50 vendors meant you had 50 different teams writing and maintaining custom scripts just to translate, say, source IP from vendor A to client data from vendor B. It was a maintenance disaster.
A total mess.
A total mess. XDM forces all of that wildly different data into one consistent standard structure.
And why is that so critical? I mean, beyond just being tidy.
Because it's the absolute prerequisite for doing anything at scale, especially with machine learning. You cannot build a smart ML model to spot a threat across your firewall data and your cloud data and your endpoint data if the fields have different names every time.
The machine wouldn't know what to look for.
It wouldn't. Normalization creates that clean, unified data lake you need for consistent correlation, for automated analytics, and for machine learning. It turns a pile of logs into actual context-rich security events.
So normalization is what lets the machine think across all your security tools at once.
Yes, seamlessly.
Okay, so the data is unified. Now we get to the final piece, rapid response. This is where security orchestration, automation, and response, or SOAR, specifically Cortex XSOAR, comes in.
Right.
XSOAR uses playbooks to automate tasks. What are the two different types of tasks you can configure in a playbook? Because you can't automate everything, can you?
No, exactly. And the power of a good SOR platform is that it manages both speed and human oversight. So the two types are automated tasks and manual tasks.
Okay, break those down.
Automated tasks are for the high-speed, repeatable, low-risk stuff. Automatically checking an IP address against threat intel, seeing if an infected machine is a critical server, blocking a known bad URL through a firewall API. They just run. No human intervention needed.
And the manual tasks?
Those are the guardrails. They require a human to provide input or an approval or some validation before the playbook can continue. You need this for high-risk actions.
It's like shutting down a production server.
Exactly. You don't want a robot making that call on its own at 3 a.m. XSOAR gives you the speed of automation, but keeps that necessary human judgment and audit trail for the really critical decisions.
That balance sounds absolutely crucial. So when a playbook is running, one task extracts the file hash, another task needs a human to confirm a user is compromised. Where does all that temporary dynamic information get stored so that later tasks can use it?
All of that dynamic data is stored in the incident context.
The incident context.
Yep. You can think of it as the investigation's short-term working memory. It's scratchpad.
Okay.
Every bit of temporary evidence, the indicators you extract, the severity scores you calculate, the user approvals, all of it gets dumped into this central repository for that one incident. It's what ensures continuity across the entire workflow, whether it's automated or manual, and even if multiple analysts are working on it, it keeps the engine running on the latest facts.
That provides a perfect view of the entire modern SecOps workflow.
If the machine, through automation, is going to handle 90% of the routine work, and the human analyst only steps in for those critical, complex manual tasks in a playbook, what new specialized skills does that analyst need to develop? Their value isn't running scans anymore. It's in strategic decision-making and optimizing the whole system. And that is where the future of the human in SecOps really lies.